Crank through 9A, should be pretty short, sharp, shiny. Get some time on the folio hopefully. I've had a few requests for a lesson on the folio, so I'm thinking maybe tomorrow, unless there's any strong opinions otherwise. No? Okay, so tomorrow's lesson will be dedicated to the folio. That means everything else gets bumped back a week, a lesson. Okay, so we're talking today about sampling distribution. So let's just have a read of what it's saying there. It says when we take multiple observations of a random variable and add them together, we obtain a new random variable. And a good example here, the weight of a carton of eggs can be found by weighing each individual egg and adding them all together. Okay, the length of time on a Netflix binge found by adding the length of each time, the time length of each episode together. So there you go. For n independent observations, the random variable x, the sum of observations is the random variable Sn. Okay, so Sn is when we're adding those variables together. If x has a mean mu and standard deviation sigma, then Sn has a mean n times mu. Okay, so if the variable x has mean and standard deviation, then the variable s has a mean n times mu, the number of samples times the mean, and standard deviation is the square root of n times sigma. Oh, I've done that the wrong way around. Sigma times the square root of n. There we go. Okay, so let's get into this example. Find the mean and standard deviation of x. So here we're going back to chapter 7 where we're talking about discrete probability distributions. And so we've got two possible events. Let's say it's a coin, you can flip it, you can get a 1 or a 2, and it's really unfair. You can get, the probability of getting a 1 is 0.2, and the probability of getting a 2 is 0.8. Now, like just to recap, to find the mean of a probability distribution is the sum of each event times its probability, and then added together. So it's 1 times 0.2 plus 2 times 0.8. We can work the mean out here really easily. The standard deviation is a bit messier. So the mean is E of x, isn't it? Remembering that? Which is going to be 1 times 0.2 plus 2 times 0.8. So that's going to give us 0.2 plus 1.6, 1.8. Okay. We'll use our calculator to determine the standard deviation. Actually, let's do it manually. There's only two data values there, so let's look back and see how we do it. Formula. Here we are, 7D, it's on page 7 of your notes booklet. Standard deviation formula, I'm going to write it here. It's the square root of the sum of each value, take the mean squared times the probability of that event, and then square root it. Okay, so we're going to perform the square root at the end. But it's going to be the sum of each event, take the mean. Okay, so the first event is 1. So this is going to be our standard deviation. It's going to be the square root of 1 take the mean, which is 1.8, squared. So the event, take the mean, squared times the probability of the event. Okay, plus because we're doing the sum of. And then the second event, which is 2, take the mean, squared, and then times the probability of the second event, 0.8, and then we're performing the square root of that. Okay, so that's going to be our standard deviation. All right, we will have to use our calculator either way. We've got 0.2 squared plus I've got 1 on 5, or 0.2. Okay, so we're probably sort of remembering that a little bit. So we've found the mean and we've found the standard deviation of x. And so some ways we can write that is like this. The mean of x, okay, the mean of the variable x is 1.8, and the standard deviation of the variable x is 0.2. Okay, what's it say to do next? State the meaning of S10. Okay, S10. S10 is going to occur. Let's say we perform the experiment probability experiment, flipping a coin, spinning a dial, 10 times, and add the results together. That will give us the variable S10. That'll be the random variable S10. And we perform the experiment 10 times and add all the results together. Find the mean and standard deviation of S10. Well, the mean of S10, okay, is equal to, it's up here, n times the mean of x, which is going to be 10 times 1.8, which is 18. Okay, so we're just finding the mean and standard deviation of S10 using those two formulas there. Calculate that one. So 1 on 5 times root 10. I think it's just root 10 on 5 is the best way to answer it. Okay, and then the last part, state the possible values of S2. Okay, so this is part D. S2, this is getting you to think about the possible events that could occur. What are the possible values you could get by performing this twice? Well, okay, think about it like this. This is an experiment we're performing, and let's again think about it like flipping a coin. The lowest outcome you could get is a 1 and then another 1. Okay, so the lowest possible value of S2 is going to be 2 because it's 1 plus 1. The highest possible value would be if you got a 2 and then another 2. So the highest possible value is 4. Okay, and then there's lots of ways you could get a 2 and a 1, or a 1 and then a 2. So the possible events of S2 are going to be 2, 3, 4. Okay, what about if we said what are the possible values of S3? Okay, 3 observations. Well, the lowest would be 1 plus 1 plus 1. So the lowest would be 3. And then the highest would be, you could get 3 2s, couldn't you? Which would be 6. So we're listing possible events, that's what's there you to think about. And then all the way in between is possible as well. Alright, so that's enough to get into 9A. Let's get started.